Alright, waters of crystallization. Waters of crystallization refers to water that is found in the crystalline framework of a salt. Right, so it's the crystalline framework of a salt, which is not directly bonded to the salt but rather attached to it. So if you think of the situation of dissolving or dissolution, similar thing, except here, what's actually happened is, I'm going to show you what actually happened then. Right, so firstly what happened was you had this container, and inside of this container you had, let's say the salt for instance is CuSO4, right? And in this CuSO4 you dissolved it in water. So when it goes through that process, we know that it's going to form this kind of setup where the Cu 2 plus ions and the SO4 2 minus ions are going to be separated. SO4 2 minus, right? So that's what it's going to look like. How they get separated like that, I'm just going to circle them, right? So they no longer, when they go through the process of dissolving, they no longer are the ions. So what actually happens then is that around the Cu2 plus, you have the water molecules doing something like this. The delta negative side is going to attach to the positive ions. Okay, so the side where the oxygen molecules are going to join to the copper 2 plus, and the sides where the hydrogens are, they're going to join to the SO4 2 minus because of the polarity of that water molecule. So it will attach itself like this and it separates the ions. So that's what happens when we dissolve something. Now if I want to take this dissolving situation and I want to go through the process of evaporation, what we want to do is we want to get rid of the water. Now the problem with that is we can't get rid of all the water. We can't completely dry that salt out. So when it goes through the process of evaporation, what starts to happen now is that instead of getting rid of all the water, you're going to end up with CuSO4, right? And attached to it is 5 hydrogens. So the salt will now form. So there's your salt. Right? So over here what you have is ions surrounded by water. Okay? But here you have your salt that's formed, and attached to the salt you have water. So you're just going to have CuSO4, and attached to it the ratio for copper sulfate is going to be 5 H2O molecules. So every single salt has this type of situation. So waters of crystallizations are the molecules of water, right? Waters of crystallization are the molecules of water that are attached to crystals that were previously dissolved in water. Right, so you're not actually going to get out the pure situation, the pure crystal. Okay, so it's not, once it gets to this stage here, it cannot just be CuSO4. That's wrong. Okay, but it has to be in its crystalline form, in its crystallization form, which is CuSO4 attached to 5H2O. Right? It means that attached to every molecule of copper sulfate, you're going to have 5 molecules of water. And this is why we call this thing, right, hydrated copper sulfate. Because it has a little bit of water attached to it. So we can say then, upon crystallization from the water or water containing solvents, many of these compounds incorporate water molecules in their framework. So after they've gone through the process of dissolving, then they go through evaporation. What they end up with is something called a water of crystallization. Now there are 2 types of calculations that we do. I'm going to show you both of those calculations, and then you guys can go through your textbook and do the activities on waters of crystallization. Alright, so the first type of calculation, it says how to calculate the theoretical percentage of the water in a hydrated salt. So let's say, for example, I had magnesium sulfate. Okay, and magnesium sulfate salt crystals. Now, if I have magnesium sulfate salt crystals, let's say I had MgSO4 7H2O. Okay, now we want to know for this type of question, this question is referring to what percentage of this crystal is water. Okay. Alright, so I'm going to give you guys the steps, and then you're going to go through each step with me, and then you can do one guided practice, and I'll show you the answers for that, right? So step 1, you're going to need the relative atomic masses. Okay. So Mg, S, and O, and you've got hydrogen. Alright, so you just go to your periodic table, use the periodic table with the whole numbers, and you should get. And once you have that, now you need to get the relative formula mass. You're not going to do it in this many steps. You'll do it in less steps as you get used to it, right? So you've got the relative formula mass of H2O, which is going to be 2 times 1 plus 16, and that's going to give you 18 AMU. Alright, then you've got MgSO4, and that's going to give you 24.3 plus 32 plus 16 times 4, and that should give you 120.3 AMU. Right, once you've got that, you need to look at, in terms of your mass of the water. So your relative formula mass of the water is currently 18 AMU, but you have 7 H2O molecules. Okay, so don't forget that. So your actual relative formula mass of your water is going to be 18 times 7, and that should give you 126 AMU. So in this whole situation here, your mass of your compound or your salt is 120.3, and your mass of your water is 126 AMU. We want to know of this total mass, how much is the water. So what we do is, right, we say the mass of the salt plus the mass of the molecules of water would give you the total mass of the crystal. Okay, you don't have to memorize this formula or anything, just know that it's an addition sum. Alright, so all you're going to do is you're going to say 120.3 plus 126, and you're going to get 246.3 AMU. So this is the total mass of your crystal. Then all we want to do is we want to know of that total mass, how much is water. And we know that this here, the 126 represents water. So all you're going to do is you're going to say the percentage of water is equal to 126 multiplied by 100 divided by 246, and that's going to give you your percentage. So pop that into your calculator, and that should give you 51.22%. So therefore, okay, 51.22% of MgSO4 7H2O is water. And there we go. Right? So nice and simple. Right? This step here you don't have to do. This step here you have to do, because you need to find three things: mass of the salt, mass of the total water, right? Then you need to add the masses to get the total mass, and then all you have to do is a percentage calculation. This is not on your formula sheet because it's ratios and percentages and so on. Alright, so all you have to do is show what method you chose. Right? So that's the one type of calculation where they give you what is given is the full formula. Okay, they give you the full formula, and then they either ask for the percentage of the salt. So what you need to find is percentage of salt, or they can ask you to find the percentage of water, one of those two. Okay, let me show you the next type of calculation. So that's what that's going to look like. Right, with this one, it's determining and the calculation of a salt formula containing a water of crystallization. So what we need to do is we need to find the formula. Okay, that's the goal. Alright, so what we first need to understand is that a known mass, okay, so that's what is going to be given to us now. A known mass of hydrated salt is gently heated in a crucible. Alright, so this is an apparatus. Go and find the function, okay, when we use a crucible, right? And when it's gently heated, the purpose is to get rid of water. Okay, now at some point, let's go move this up. At some point, it's going to be heated until no further water can be lost. And the weight that remains, or the weight remains constant, despite heating it more. That's how I know no matter how much I heat it, it's going to stay. So what we do is we measure the amount of anhydrous salt, right? That's left over. Okay, then what we do is you also have to know the original mass of hydrated salt and the mass of the anhydrous salt Alright, so the original mass of the hydrated salt and the mass of the anhydrous salt residue can be worked out using those weightings. Okay, so this is the process. You have to know the process, because what's going to happen is, in an exam or in a test, right, we're going to give you a scenario. I'm going to give you a scenario. This is the kind of scenario that you're going to come across. And then you need to understand you're working with waters of crystallization. Alright, so let's have a look at how the example for this thing works. Alright, so let's say, for example, they say, suppose 6.25 grams of blue hydrated copper 2 sulfate, which is CuSO4 XH2O. Right. The X is unknown, so we don't know how many moles of water is attached to it. Was gently heated in a crucible until the mass remaining was 4 grams. Right? And what this is the white anhydrous copper 2 sulfate. Okay, so we started off with the blue, now you have the white. We want to know what is the formula of the hydrated salt. Right. Now in a question like this, when they want the formula of the hydrated salt, what you need to do is, we need to find the value of the X. That's the goal. Okay, so when you see this in an exam or test, then know that they want that X over there. So I'm going to give you the steps on how we work that out. Okay, so take down the question and then work with me. Take out a calculator, make sure you're doing the work. Alright, so let's start. Step 1, right? First you need to get the change in mass. Okay, of the anhydrous salt. Oops. Okay, so we know, oops, let's do that you had 4 grams, right, after the water. And so therefore you're going to, and you started off with 6.25 grams. Okay, this was before the water. Remember, you're not going to do this many steps, you're going to do it all at once. So you're going to go 6.25 minus 4.00, and that should give you 2.25 grams. So there's your change in mass. Okay, so now we want to know, the second step is, we need to find the percentage of waters of crystallization. Okay, so all we're going to do is we're going to say 2.25 multiplied by 100 divided by 6.25, and that gives me 36%. Okay, So there's the first two steps that you've got done. Right. The third step that needs to be done is you need to look at the mass ratio. Okay. Alright, so all you're going to do is you're going to look at your two compounds and you're going to look at their ratios. So you've got CuSO4 is to H2O. Okay. So we know that the CuSO4 is equal to 4 grams and the H2O is the 2.25 grams. So the 2.25 grams here, right, is the loss of water, isn't it? Because this is what it was before the water and then what it was after the water leaves. So that loss of water is that 2.25 grams. So you look at the ratio. Your salt is 4 grams and your water is 2.25 grams. Right. So now what you have to do is you have to convert the mass ratio into a mole ratio. Okay, so you know how to do this. N is equal to M over big M. So all you're going to go here is you're going to say 4 divided by your molar mass of copper, which is 63.5 plus 32 plus 4 times 16. Oops. It's 4 divided by 159.5, and that should give you 0.02507 moles. So I'll hold that is to 2.25 divided by 2 times 1 plus 16, so that's 2.25 divided by 18, and that should give you 0.125 moles. Okay, once you've got that, you've now isolated your molar ratio between the two things. Okay, so I'm just going to show you how the ratio works, and then you can, this is normal ratio calculations from grade 9. So the CuSO4 is to H2O, 0.02507 is to 0.125. So how we get the ratio there is we divide both sides by 0.02507 by the smallest. So make sure you divide both sides by the smallest ratio. Okay, and 0.02507, and this should give you 1:5. Okay, so that means for every copper sulfate you must have 5 H2O. So therefore the formula of the hydrated salt is CuSO4 is to 5H2O, and therefore X is equal to 5. So there we go. Alright, so I'm just going to talk you through it and let's have a look what we have to do. Alright, so the first thing you need to do is you need to find the change in mass of your anhydrous salt, which is going to give you the loss of water. Once you do that, you need to find out what percentage of that is going to give you your water of crystallization. Right, once you get that sorted out, then you look at your mass ratio. After your mass ratio, you do number 4, you convert the mass ratio into a mole ratio. So mass to mole, and you can just use N is equal to M over M. Right, once you've got that ratio, divide both sides by the smallest ratio, and then you should get a whole number ratio. Once you get the whole number ratio, that should lead you directly to your answer where you are looking for X. What I want to have a look at now is a few other ways of how they can ask you these questions. So I'm going to just put the questions up. I'm going to go through the answers with you. It shouldn't take too long. I'm going to do a few examples with you, and then you can do the exercises in your textbook and so on. Right, it says a sample of hydrated calcium sulfate, CaSO4 dot X H2O has a relative formula mass of 172. What is the value of X? Right, so the first thing you need to do is you actually need to find out your total or whatever the case is. So I know it's always the mass of the salt plus the mass of the water that's attached to it. That gives me my full thing. My problem is I don't know that X over there. Alright, so I'm going to put in what information I do have. So I've got CaSO4 plus X H2O. So I need to find the X H2O. Okay? And I know that this whole thing together, so it's just like mass, this whole thing together must give me 172. So we're looking for X. So we're going to go and we're going to say 40 plus 32 plus 16 times 4 plus, and I'm just going to make it a variable, X plus 2 times 1 plus 16 is equal to 172. And we need to find X. Okay, so we'll come back to that. Okay, so what I've got is 136 plus 18x is equal to 172. And then like terms, unlike terms, move things over. And then x should be equal to 2. So that's one type of question where you work it out like that. Okay, so what they've given you here is the salt, the formula of the salt, but they don't know how many moles of water you have, but they do know the total mass. So we want to know what portion of that. So therefore, it's going to be CaSO4 dot 2 H2O. That would be the formula. And remember, try and do these by yourself. If you can't do it by yourself, that's fine too, right? Alright, it says here, a hydrated salt is found to have the empirical formula CaN2H8O10. What is the dot formula? Right, so they want the salt dot H2O formula. Now we know that the empirical formula is the simplest ratio of atoms that combine. Right? We also know that we want a salt and we want H2O. So if I look at CaN2H8, H8O10, the first thing I need to do is, in this thing, how many times can water go into this formula? Now water is H2O, okay? So if I have H8, okay, that means, so if I'm looking at H8, H8 tells me, right, that can only make 4 water molecules. Right, because every water molecule must have 2 hydrogen atoms and 1 oxygen atom. So once we eliminate that setup of using all H8, then each of those H's must use, each 2 hydrogens must use 1 oxygen. So every one of these 4, 1, 2, 3, 4, get an oxygen, 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 oxygen. So then you have left over for the salt, they get 6 oxygens. Right, so that helps us a little bit. So I know that it's going to be 4H2O. So I'm pulling from this empirical formula. If I pull 4H2O, then if I have CaN2H8O10, and I take out 8 H's, I took out all the 8's, and from here I took 4 O's. What I'm left with is then I'm left with Ca, okay, N2O6. And that gives me my formula of my hydrated salt. So for this question, a little bit different now. You got to see how many times does H2O, the molecule, fit into the empirical formula. So this, what they've given you is the number of atoms available. What they want you to do is turn it into a salt and its water combination, right? It says a hydrated carbonate of an unknown group 1 metal has the formula. So they've given you the formula. X2CO3 times 10 H2O. And is found to have a relative formula mass. So this thing is going to have a relative formula mass of 286 AMU. They want to know, what is this? Okay. Same as the other one. The other one, the X was just in a different place. So all we're going to do is we're going to write an expression. I know that I need 2 of the group 1 metals plus carbon plus 16 times 3, which is your oxygen, plus 10 times 18. Okay, and that should give me 286. And we want to know what is this X over here. Alright, so if we add all of that up, you end up with 2X plus 240 is equal to 286. 2X is then equal to 286 minus 240, and that gives you 46. And divide both sides by 2, just basic math, right? And then X is equal to 23. Right, so you need to find the atom that has an atomic mass of 23. And if I look at my periodic table, it says that Na, or sodium, has an atomic mass of 23. So the answer for X is then equal to sodium, or Na. So your salt actually looks like this. NaCO3, Na2CO3 times 10 H2O. Alright, so this one is a little bit different. The X was in a different place, but again, you use math expressions, find the X value, and remember, what we're working with here is mass. So whatever your X value is all, these values here are all contributing to the mass. Right, it then says, a teacher told a student that the amount of hydrated salt in Lansfordite was 0.03 moles, and the amount of water lost on heating was 0.15 moles. Calculate the value of X in the formula MgCO3xH2O. Alright, so the first thing over here is what they've given you. So what is given to us is the mole ratio. Okay, they're giving you the mole ratio. So you've got MgCO3 is to xH2O. Okay, and they're saying that the hydrated salt was 0.03 and the water lost was 0.15. So this was 0.03 is to 0.15. Then remember what I said, divide both sides by the smallest one. So 0.15, what am I saying, divided by 0.03. So they've already given you this mole ratio. So this is going to be 1. And 0.15 divided by 0.03 is going to give you 5. So therefore, right, there are 5 times more water than MgCO3. So X is then equal to 5. So therefore the salt looks like this. MgCO3 times 5H2O. Right. So normally we get the mass ratio. And then from the mass ratio we go into the mole ratio. Right? That's our normal thing. But here you already given the mole ratio. So all you need to do is work out the simplest whole number ratio, and that should give you your value of X. Alright, 11.25 grams of hydrated copper sulfate, CuSO4xH2O, is heated until it loses all of its water. Its new mass is found to be 7.19 grams. What is the value of X? Alright, so this is something we've done before. Try and do this one by yourself. Pause the video, press play when you're done. Okay? Alright, so what I want to do is I want to say CuSO4 times XH2O. That gives me 11.25 grams. Okay? CuSO4 gives me 7.19 grams. And the XH2O, that gives me the change in mass, which is the 4.06 grams. Right? Which I got from saying 11.25 minus 7.19, and I got that value there. Okay. Alright, so what I need to do now is I need to do my mole to mole ratio and my mass to mass ratio situation. Okay, so I'm going to go CuSO4 is to XH2O, and that's going to be 7.19 is to 4.06. Right. Now I need my mole ratio. Okay, so I write N is equal to M over M here. I'm going to get 1 mark for it. I don't need to do it multiple times. So I'm going to go 7.19 over 63.5 plus 32 plus 16 times 4. Don't forget all your brackets and so on. And on the other side, I'm going to go 4.06 divided by 2 times 1 plus 16. Right, and I should get 0.04508, and I should get on the other side 0.2256 moles. And remember, we're doing a ratio calculation. Right, if I look at these two, I must divide both of them by the smallest ratio, which is the 0.04508, 0.04508, and here I'm going to get 1 is to, right, 5.006. Now just round that off, 1 is to 5, and therefore X is equal to 5. So my hydrated salt is CuSO4 times 5H2O. And there we go. Alright, so same thing. Get your change in mass and find the water loss. Do your mass ratio. Oops. So that's in grams and grams. Then do your mole ratio. Right. Then you find the whole number ratio, and that is usually the value of X. And here's an exam type question. It says 13.2 gram sample of zinc sulfate ZnSO4xH2O was strongly heated until no further change in mass was recorded. On heating, all the water of crystallization evaporated as follows. Calculate the number of moles of water of crystallization in the zinc sulfate sample given. That 7.4 grams of solid remained after strong heating. Again, try and do this one by yourself. See if you can get to the same answer. Alright, so what I want to do here is find my change. So I started off with 13.2 grams minus 7.4 grams, and that should give me 5.8 grams. So this here is my salt, which is ZnSO4, and this here is my water loss, which is my H2O. Okay, so I go ZnSO4 is to H2O. We don't know what the X is. And we've got 7.4 is to 5.8. Okay, so this is in grams. We want it in moles. Okay, so you're going to go N is equal to, and you always write this down because you're going to get marks for this. So you write it down once, you get the mark once. All right, so you're going to go 7.4, 7.4 over 65 plus 32 plus 64. That should give you 161, and that will give you 0.045963 is to 5.8 divided by 18, and that should give you, and that gives you moles. Yes, make sure you write down moles because that's a valid SI unit, right? 5.8 divided by 18 is going to give you 0.3222 recurring moles. Right, again, get your molar ratio, divide both sides, in this case 0.45963 divided by 0.04563, and these will cancel, so I'm going to get 1 is to 7. Right, so therefore X is equal to 7, and it will read ZnSO4 is to 7 H2O. Right, so all this says is there are 7 times more. That's what this 7 tells me. Water molecules than zinc sulfate. Okay. And the last one. It's a bit of a backwards one. It says a sample of hydrated magnesium sulfate, MgSO4 XH2O, is found to contain 51.1% water. What is the value of X? So we're just going to work it backwards, right? So what we're going to do is we've got 51.1% H2O, and we've got our salt is MgSO4 times H2. What am I saying? XH2O. Okay, once you've got that, the first thing you need to find out is what percentage of this, right, is your salt, right? So all you're going to do is you're going to say 100% minus the 51.1%, and you should get 48.9%. Okay. The second thing you want to do is you want to look at your percentage. So what you've got now is percentage ratio. So you've got MgSO4 and XH2O, and you've got 51.1% is to 48.9%. Now this percentage gives you 100%. And remember, if something gives you 100%, it actually gives you a 100 gram sample. So that can be converted into grams. So you've got 51.1 grams is to 48.9 grams. So once you've got your grams, you can now find, so you've got, here's your percentage ratio, and you've got your mass ratio. We don't want that. We want it in moles. We want the mole ratio. So N is equal to little m over big M. and you've got 51.1 over 24.3 plus 32 plus 64, and that should give you this. And here you've got 48.9 all over 18, and that should give you that value, right? So once you put this into your calculator, you're going to get 0.42 47714 moles, and on the other side you're going to get 2.71666666 recurring moles there. All right, again, divide both sides by the smallest ratio, 4247714 over 0.42477714. All right, that's going to give you 1:6.967, so on. We round that off, 1:7. So therefore x is equal to 7, and what my salt now looks like is MgSO4 7H2O. And what you guys would have noticed now, that's your answer, right? Don't forget you're getting an answer there. So if I had to give you marks here, let's how I will give you marks. 1 for sorting that out, 1 for sorting your mass out, 1 for your formula, 1 for substituting each side, 1 for finding the moles on both sides, 1 for doing your ratio, and 1 for your answer. When you're working with something like this or this situation, please remember, if they're asking you to find the value of x, then you find the value of x. This part here that I'm showing you here is what your salt looks like. What you would have also noticed is that MgSO4 will always have 7H2O. Copper sulfate is always going to have 5H2O. It just means that every time it does this situation, it bonds in that kind of a ratio. So those types of things are fixed. If you get MgSO4 and you end up at 6H2O, then that's a problem. Alright, so please make sure that you're picking up patterns when it comes to this section.